Hello there, my name is Gary Sims from Android Authority. Now, we often talk about the exterior of our smartphones. Maybe we talk about the design language, we might talk about the materials, the texture, how it feels in the hand and so on. But have you ever wondered about the inside of your smartphone? What's going on the inside? What are all those different components and what do they do? Well, if you've ever wondered, please let me explain. So probably the most obvious component of your smartphone is its display. Although it has an outward facing surface that we use to interact with the smartphone, it is actually an internal component of the smartphone. Now, display technologies today in smartphones come in two main types, those based on LCDs and those based on LEDs. And from that we get the IPS technology and we get AMOLED or Super AMOLED technology. Now, the difference between the two is this: on an LCD based display, basically there is a backlight that is shining through some polarizers, it's shining through some filters, and by manipulating the crystal display, we can get different colors coming through on the other side. Now, that means that actually the light is not being generated by the display itself, it's being generated by this light behind the display, and then only some of the light is coming through onto the other side. Now, with an AMOLED display, actually the LED bit, LED, is light emitting diodes. So each of the pixels are made up of these little light emitting diodes, LEDs, that produce probably red, green and blue. And so it's actually the display itself that's generating the different colors. Now, the advantage of an AMOLED display over an LCD display is that when a pixel is off and it's actually showing black, it is actually not using any electricity because it's actually black, it's switched off. And that means you get power saving. It also means you get great black, very deep blacks, and it means you get a good contrast. Whereas with an LCD, when something is black, what's actually happening is the crystal display is being manipulated so that none of the light gets through, but the light itself is still being generated in the backlight behind it, so there's no power saving advantage of that at all. And next up is the battery. Now, batteries come in two main types, either those that can be changed, user removable batteries, you peel off the back, you can take the battery out, you can put another one in, or those that are sealed inside your mobile phone. Now, batteries today mainly use a lithium ion technology, which means you don't have to worry about that kind of memory effect we had many years ago about how you charge your phone and have to charge it and discharge it and so on. We don't have those problems today. However, the size of the battery is an important factor, and the average today seems to be about 3000 milliamp hours for a 5.5 inch kind of device. Now, once you go deep inside your smartphone, the biggest, most important component is the system on a chip. Now, the system on a chip is not just a CPU, the central processing unit, it's actually a whole bunch of different bits of silicon that are all put together to give you a highly functional system on a chip. So you've got the CPU, you've got the GPU, you've got L1 and L2 caches, you've got a display processor, you've got a video processor, you've got a DSP. There's a whole bunch of things that go in there that make this system on a chip. Now, when it comes to CPUs, today basically all smartphones use the system architecture from ARM. So ARM work by licensing their intellectual property, their designs to other people, and they incorporate them inside of their chips. So you might have heard of things like the Cortex-A53, the Cortex-A57, the Cortex-A72, the Cortex-A73. These are all ARM designed CPU cores that companies like Qualcomm and Samsung and Huawei and MediaTek all put inside of their system on chips. There is actually a second category of ARM type processors, which are those companies that own an architectural license from ARM, which means they have the right to design their own CPU cores as long as they are compatible with the ARM instruction set. And Qualcomm has one of those licenses, so does Apple, interestingly enough, so does Samsung. And so chips like the Cryo core that you find in the Qualcomm 820 and 821 were proprietary design chips by Qualcomm using an ARM architectural license. And next up is the GPU. There are three main players. You've got Qualcomm with the Adreno GPUs, you've got ARM with their Mali GPUs, and you've got Imagination with their Power VR GPUs. Imagination really aren't that popular as ARM and Qualcomm. You find them occasionally in a MediaTek chip, you might find them in a Samsung chip occasionally, but mainly you find them in Apple's processors. Whereas Qualcomm, all of their Snapdragon processors have the Adreno GPU in it, and basically chips from Samsung and from MediaTek and from Huawei all have GPUs from ARM in them. Now, once you have this powerful CPU-GPU combination, there are still a few more blocks that you need to really get that full multimedia experience on your smartphone. One of them is a display processor. That's really the interface between what's coming out of the GPU and CPU and your LCD or LED display. And then you also have a video processor. When you're watching YouTube, when you're watching Netflix, all that data is coming down compressed, MP4 for example, and it needs to be decoded. Now, it can be decoded in software, but it's much better if it's decoded in hardware, and that's the video processor. But it also does encoding. So if you're using a video chat application, you're talking to somebody, what's being captured on the camera needs to be encoded so that it can be sent up into the internet and then onto the other person. And again, the video processor does that in hardware, and they're all included on the system on a chip. Now, no system can run without memory and without storage. So when we talk about memory, we're talking about random access memory, RAM, and a typical Android 7 based smartphone will have about 2 GB of RAM as a minimum. And then we might have 4 GB, that's pretty usual. There are some now with 6, and there's talk about some coming with 8. So that's random access memory. It comes in two types. You've got LPDDR3 and LPDDR4, the LP bit being low power, where it reduces the voltage compared to what you get on the desktop, and obviously LPDDR4 is faster than LPDDR3. And then there is internal storage. That's basically the amount of storage space that you've got for the Android operating system, for your apps and for all your multimedia. 8 GB kind of exists in some low-end phones. 16 GB is really the kind of the minimum, practical minimum. And then of course you've got 32, 64 and so on after that. One question, of course, is that do you really get 8, 16 or 32 GB of space? No, you don't, because Android itself takes up a fair portion of that space. So if you've got an 8 GB phone, you may only get 3 or 4 GB of free space on it. If you've got a 32 GB phone, you may find that even as much as 7 or 8 GB is taken over by Android for things like the operating system itself and for over-the-air updates and for other things like that. So you're not always going to get the full amount that's written on the box. And of course, smartphones are still phones, so somewhere in the inside of your smartphone, there needs to be some connectivity options, cellular options. And today, of course, we talk about 2G, 3G and 4G LTE. And to talk to those networks, those cellular networks, your phone needs a modem. And all of the major SoC builders have their own modems. So Qualcomm have got their range of modems, Samsung have, Huawei have, and MediaTek have. Now, the top three, Samsung, Qualcomm and Huawei, basically are pretty equal with each other. Qualcomm is probably always in the lead just a little bit, but here you're talking about the most advanced LTE modems that you can get on the market. And MediaTek, because it aims for a different category of phone, they tend to have still support for 4G LTE, but much slower category of modems. They're not advancing as quick as the other ones, but that's not so bad, because remember, you might have a smartphone that supports the absolutely latest and greatest LTE standards, but if your own network at your home country doesn't support them, then it really doesn't make any difference. Of course, MediaTek are going for that different segment market. Other connectivity, of course, options beyond LTE are, of course, Bluetooth, Wi-Fi and NFC, and there will be chips inside of your phone that specifically work for those things, and they tend to be built by companies like Broadcom and NXP. So if you hear those names, they're the people that are building the connectivity chips in your phone. And then, of course, we come to the camera. Now, most phones nowadays have a front-facing camera and a rear-facing camera. Inside that camera, you're going to find three different components. There's the sensor, which actually detects the light. There's the lenses that light comes through, and then there's the image processor. Now, obviously, we know about megapixel count. We've been talking about that for years. I've got an 8 megapixel camera, I've got a 16 megapixel camera, but megapixel count isn't the only thing that's going on here. Really, the sensitivity of the sensor is incredibly important, and how much noise it generates in low light situations is also important. And once the light has entered through the lens and it hits the sensor, that data needs to be processed to create you a photograph. And particularly when we're talking about things like filters and the different effects you can add, and we're talking about HDR photography, there is a piece of hardware called the image signal processor, which basically takes the data from the camera sensor and it creates the JPEG files that we actually have, which are our actual photos. And all of these major SoCs have image processors built into the SoC, so that it can do that stuff like HDR and the other image color correction and other image processing like that. Of course, we also use our smartphones for audio, whether it's just having a conversation with somebody, whether it is listening to music, whether it's watching a YouTube video. Audio is an important part, and there are several different components to the audio system in your mobile phone. Of course, there's the speakers themselves. Sometimes we have rear speakers. I've seen a phone with a side speaker. Often they're on the bottom or edge of a smartphone. Of course, there are the front-facing speakers, which generally today are considered to be the best speakers that you can get on a phone. But the speakers aren't the only thing that you need. You also need a DSP, a digital signal processor, which will do things like the equalization processing for the audio that's coming out of your mobile phone. And you need a DAC, a digital to analog converter, and that takes the digital signals, the ones and the zeros, and turns it into an analog signal that can power a speaker or go down your headphones into your ears. And that obviously, again, you get different quality DACs. Some are more noisy, some are higher quality, and some smartphone manufacturers make a big deal about the DAC that they put inside their phones. And then lastly, a few more things just to mention. You've got a GPS chip somewhere in your phone that's kind of used for the location services, detecting the satellite signal so it works out where it is on the planet. You've actually got a tiny little vibrator motor so that when your phone vibrates, when you've got it on silence maybe, there's a little motor in there that actually does that. There's of course the port, which you use for charging and for data transfer. That would either be a micro USB port or a USB Type-C port. And of course there's the headphone jack, which you might not get on some phones nowadays, but hopefully you do also have a headphone jack. Otherwise you're just relying on Bluetooth only for connecting to your audio equipment. My name's Gary Sims from Android Authority. I really hope you enjoyed this video. If you did, please do give it a thumbs up. Don't forget to download the Android Authority app. Please subscribe to Android Authority's YouTube channel, and please go over to androidauthority.com because we are your source for all things Android.